All right, Unit 6 review. This is analytic trig. And again, we're trying to simplify these trig expressions using these different tables over here. And again, it's like a puzzle. My goal is to try to manipulate things, change them using these identities, basically. And I want things to cancel out and go away and shrink up, just like any algebra or math problem, I guess, for the most part. All right, now the first thing I would do is I would notice, and there's multiple ways of solving this, but this is what I would do. And I would notice on number 4 here is they both have a sine squared here. So I'm going to take sine squared out of both of those. So I have sine squared x. And if I took a sine squared out of this first term, I'd be left with 1. And if I took a sine squared out of this second term, I'd be left with a positive cotangent squared x. Okay, the next thing. Usually, when I notice if one of the trig expressions has a squared with it, this Pythagorean identities table is used often. Now, don't be confused by, like, it looks like kind of a jumbled mess, but basically each row is the same equation. So, for example, all 3 of these equations are exactly the same. Okay, in this first one, you'll notice that it's sine squared and cosine squared are on the same side. And then basically these next ones just solved. Like, what if I wanted sine squared by itself? You'll notice, oh, I would have to subtract cosine squared to get this. Hopefully that's apparent. And then the next one is, what if I want cosine by itself? And you'd say, oh, look, I would have to subtract sine to get this. Okay? So again, all 3 of those are the same. Now, I don't want one of these that has sine or cosine in it. I want one that has cotangent in it. So my next goal is, I notice right here, okay, 1 plus cotangent squared. And I'm going to look at my table, and I notice the bottom row has cotangent in it. And I notice this very first one here, I notice 1 plus cosine. So, or cotangent, excuse me. 1 plus cotangent squared is equal to cosecant squared. Okay, so all of this here is going to turn into cosecant squared of x. So it was 1 plus cotangent, now it's cosecant, times sine squared of x. Okay, the next thing I can do here is I'm going to go ahead and look at these reciprocal identities. Now, these reciprocal identities also work with squares. And I notice the very first one here, cosecant of theta is equal to 1 over sine of theta. Now, if I were to square this left side, okay, I could square the left side as long as I squared the right side. And if I squared there, that would just turn into 1. And if I squared down here, okay, so technically, all of this right here is going to turn into 1 over sine squared. So now I would have this equals sine squared of x times, sorry, there's a little glitch in my board here, sine squared of x, let me move it up, times 1 over sine squared of x. And these would cancel each other out, and my final answer here would be equals to 1. Okay, next one. I'm going to go ahead and erase my markings on these tables. Okay, you'll notice that I have negatives here. So I have negative x, negative x. The only place I see that on the table is down here in the odd even identities. And the first one says sine of negative x. I notice right there. So you'll notice the negative moves away from the x and it floats out front. And then I also have cosecant negative x. And I get the same thing. So now I have sine of x with the negative out front. Don't forget these are being multiplied. Here's the biggest mistake. I see people want to just automatically switch to add addition and subtraction. Negative cosecant of x. And then again, I'm going to roll back up to these top identities. I'm going to leave sine alone, but I can change this into 1 over sine. So now I have negative sine of x times negative 1 over sine of x. And these are going to cross cancel. And when I multiply two negatives, they make a positive. And again, my final answer here is 1. Okay, last one. Okay, 1 plus tangent squared of x minus secant squared of x. I have a couple options here. I do notice that when I see these squareds like this, I'm probably going to focus on these Pythagorean identities. And this one's kind of interesting. I notice right here, I'm on the very first line of my second row here. I notice I see 1 plus tangent squared, just like this. And all of that is equal to secant squared. So all of this here turns to secant squared of x. So it was 1 plus tangent squared, now it's secant squared, minus secant squared. Now this is a scenario where these would cancel out, and my final answer would just be 0.